We're going to expand upon our knowledge of solving equations to now going to writing equations. So, first thing we want to make sure we understand is what is the difference between an equation and an algebraic expression? And it actually is very simple. An equation has an equal sign. Okay? Now, example, 5x plus 6 is an algebraic expression. I can't do anything with this unless I am told what x is equal to, or what value of x I want to use. An equation would take that and now tack on equals something else. And now I can actually figure out what x is equal to. Okay? Now, what we want to do next is identify buzzwords that we will see in word problems, because the key, what we want to do today is make sure we understand buzzwords and how to translate words into mathematical statements in order for us to be able to solve word problems. So what are the buzzwords associated with the plus sign? Well, plus, increased by, more than, total of, sum of, and added to. We want to be definitive that it's actually addition. Words like together or combining aren't clear enough. For the minus sign, minus, difference of, decreased by, fewer than, less than, subtracted from. Okay, for the multiplication symbol, we have times, product of, multiplied by, and then just the word of, which you normally see associated with percent problems. 30% of 20 is what? And then the division symbol, divided by, quotient of, divided into, and ratio of. Next, we want to explore what are the steps to solving a word problem. Some of these should be very apparent to you, and it's important that you follow these steps as much as possible. And I'll point out instances where not all the steps will necessarily be used. Now, the first step for certain is we want to read the problem to get an idea of what is happening with the situation. Okay. Step 2, we reread the problem and underline key facts and terms. Step 3, cross out unnecessary information or words. Now, this step I have mixed feelings about, because I don't want you to be in a situation of crossing something out that actually ends up being important. So things that you should be looking to cross out are small prepositional words, it, the, of, and, that clearly do not lend itself to helping solve the problem. It's just to make the English part of it flow. 4, assign a variable or variables to what is unknown, or what you are solving for. It is preferable to have only one variable. You can normally or usually determine what the variable is associated with by the question you're being asked. How many miles were driven? How many people went on the trip? How many minutes did you use on your cell phone? Things of that nature. Number 5, another optional. Draw sketches, pictures, or models, if helpful. Now, that really depends. Some students like to lay out things that are happening repeatedly, model form or something like that. But a very typical situation that we're talking about is if you're given a problem that involves a geometric figure, the perimeter of a rectangle or a triangle, a lot of times it's helpful to draw out the figure and label the parts. Okay, number 6, translate the key terms into math symbols so as to write an equation. So now you're going to be looking for those buzzwords that we've talked about to be able to set up your equation. Solve the equation. Okay? Usually the equations that are set up in word problems are much simpler than what we've been dealing with because the fact patterns can't be that sophisticated. Now last, a very important tool is to go back and determine if your answer makes sense. Based upon the facts given. So an example would be if you're solving for the length of a side of a rectangle and you come up with a negative number. Well, you can't have negative length. That's a very perfect example. But it really is more of a logic concept as to whether the answer makes sense or not. All right, now we want to take the following algebraic or phrases and translate them into algebraic expressions. Okay? So 3 times a number increased by 5. It doesn't matter what variable you use. I'll try to use B. I'll try to use different variables just so that you see that it doesn't matter. The quotient of a number in 2. 9 minus a number. Okay? And if it helps you, 9 minus sign a number. Okay? Usually a good idea. 5 more than twice a number. And when this orientation's off, it's off. Okay. 4 less than 6 times a number. This is one of those situations you've got to be careful for because the expression doesn't follow the words. The example I give is if I said to you, what is 4 less than 10? You would hopefully tell me that's 6. Well, 4 minus 10 isn't 6, but 10 minus 4 is 6. So less than is one of those key buzzwords that tells you to flip the order around. 3 times the sum of 7 and a number. That means I have to do that summing of the 7 and some number first. And that goes inside parentheses. It's another situation you've got to be careful about. The difference of 9 and the quotient of a number, A and 6. Two-thirds of the difference between 6 and a number. So this is telling me take 2/3 of the difference, all right? That means I got to do that subtraction first. The product of 8 and a number increased by 12, and then finally 20% of a number. I would write it as 0.20 in decimal form because I don't apply a percent to a number. So, just to recap, we're now working on translating phrases into algebraic expressions that will enable us to be able to write equations for and solve word problems.